Welcome to Technogate. Myself Jagan, I'm the physics faculty in Technogate. In last video, we discussed about something about the atoms. We have discussed what is Dalton's model and Thomson atomic model and Rutherford alpha scattering. What are the merits? Merits we discussed here. Number of scattering elements, scattering of alpha particles, and impact parameter, and radius of closest approach, and there is some relations we have discussed. In this video, we are going to discuss about Rutherford alpha scattering merits. What are the success? What are the and demerits? What are the failures of the Rutherford alpha scattering? Then we'll go to the Bohr's atomic model. So merits of Rutherford alpha scattering. So he has given statement: total atom, total mass and positively charged particle are concentrated at a particular center, and around the center electrons are revolving, and total atom is empty. Total atom is empty. So from that statement, he has done experiment. Then he verified. He has given experimental result, that is size of nucleus. Size of nucleus is 10 power minus 15 meters to 10 power minus 14 meters. Size of the nucleus is, here if you take an atom has a nucleus occupies some volume. Around this atom, electrons are rotating. He has given size. He has given that size. This is the size from here to here. The volume of, or the size of the nucleus is how much? 10 power minus 15 meters to 10 power minus 14 meters. If you convert it in a centimeters, 10 power 1 meter is equal to 100 centimeters. So if you into 100, if you do 100 minus 15 into 10 power 2, so minus 13 centimeters to 10 power minus 12 centimeters. So this is the size of the nucleus. By experimental result, let's find out. Then what is the size of the atom? What is the size of the atom? Always size of the atom is more than the size of the nucleus. Size of the nucleus is this one. What is the size of the atom? Size of atom is 10 power minus 10 meters. So compare 10 power minus 15, 10 power minus 10 is more than the 10 power minus 15, right? So the size of the atom is 10 power minus 10 meters. That means this is the nucleus, this total atom, this total size is 10 power minus 10 meters. Here is a 10 power minus 15 meters. How many times more than the size of the atom is? How many times more than the size of the nucleus? Size of the nucleus కంటే size of the atom అనేది ఎన్ని టైమ్స్ ఎక్కువ ఉంటుంది? ఎన్ని టైమ్స్ ఎక్కువ ఉందంటే, రైట్, size of nucleus is 10 power minus 15 meters. We can call it as a 1 Fermi. Fermi is equal to 10 power minus 15 meters. 10 power minus 15 meters అనుకుంటా Fermi లో 1 Fermi అంటారు. 1 Fermi is the size of the nucleus. Size of atom is 10 power minus 10 meters. That is equal to 1 angstrom. 1 angstrom. 1 angstrom. Right, in terms of Fermi, this one, 1 angstrom. Then, the size of atom is how many times more than? Here 10 power minus 15, 10 power minus 10. So, the size of atom is 10 power 5 times more than the 10 power size of the nucleus. Size of atom is 10 power 4 to 10 power 5 times more than size of nucleus. So this has given by the Rutherford by experimental result. So the size of atom is 10 power 4 to 5 times greater than the size of the nucleus. This is the merit or success of the Rutherford alpha scattering. So one more from this test has given total atom is empty, almost total atom is almost empty. So these are the merits. And what are the demerits? What are the failures of the Rutherford? Failures. Failures. Failures of Rutherford alpha scattering. First one, he does not explain hydrogen spectra. What is hydrogen spectra? We will discuss later. But he does not explain the hydrogen spectra. Doesn't explain hydrogen spectra. One more thing is, he doesn't explain the stability of the electron. Stability and so ఎంత ఎనర్జీ ఆర్బిటాల్లో తిరిగి రొటేట్ అయ్యేటప్పుడు ఎంత ఎనర్జీ ఉంటుంది, రైట్? సో ఇది వేరే ఆర్బిటాల్కి వెళ్తుంది, వెళ్ళినప్పుడు ఎంత ఎనర్జీ రిలీజ్ అవుతుంది. ఇట్ డజంట్ ఎక్స్ప్లెయిన్ ద స్టెబిలిటీ ఆఫ్ ది ఎలక్ట్రాన్. సో డజంట్ ఎక్స్ప్లెయిన్ stability of electron. And also here we can say that fine structure, so it's not required. So these are the main things, main failures. He doesn't explain the hydrogen spectra and he doesn't explain the stability of the electron. So this is about the Rutherford alpha scattering. We will discuss problems on the Rutherford alpha scattering in later videos, next videos. Right? So next, after this one, there is another model is there to explain the stability of the electron and to explain the hydrogen spectrum and to explain the what is the energy of the electron, right? So there are so many parameters are there. So all those parameters explained in a next model, that is Bohr's atomic model. Bohr's atomic model. Bohr's atomic model. In Bohr's atomic model, right, he has given, there are three statements, we can call it as a postulates. Bohr's postulates, three postulates. That is, first postulate is orbits circular orbits. Circular orbits. He has given statements, he has given some postulates. That is circular orbits. As per Rutherford, there is a nucleus is there, nucleus around the nucleus, electrons are rotating, but electrons are in which orbit it is rotating, he doesn't explain. He doesn't explain the stability. Here, he said that, both say that, there is a nucleus is there, an atom, in that atom, total positive charge and mass is concentrated at the center, that is called nucleus. Right, around this atom, nucleus, electrons are rotating in a discrete orbits. I say the discrete orbits. Discrete orbit means, so these electrons in a particular orbit only. But this word Rutherford doesn't explain. Right. So he said that just electrons are revolving around the nucleus, but where, in which orbit it explains, rotating, he doesn't give any explanation. But here he said that in a particular orbit, this electron doesn't move, doesn't rotate here. This electron doesn't rotate here. So these are called particular orbits, discrete orbits. We can call it a discrete orbits. So electrons. Here electrons are rotating in a circular orbit and discrete orbits. So this is called this is the circular orbit, law of circular orbit. So from this, if anything, it has to be rotated in a circular orbit. There is a centripetal force should be equal to the centrifugal force. Centripetal force should be equal to the centrifugal force. Here, centripetal force. This is the nucleus. It's an electron. There is a force between electrostatic force between the nucleus and electron. Already it will come in the electrostatics. And centrifugal force is mv square by r. Mv square by r. So because it has some particular mass and it is moving with some velocity and radius. R is the radius. What is radius? How it will be varies? What is velocity? How it will be varies? We will discuss later. So mv square by m is the mass of the electron, v is the velocity of the electron which is revolving around the nucleus, and r is the radius. Which should be equal to. There is an electrostatic force between the electron and nucleus. That electrostatic force is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught into Q1 Q2 by R square. Q1 Q2 by R square. Here Q1 is electron charge is E. Q2 also positive charge, same E by R square. So this is the condition to rotate electron in a circular orbit. So this is the first postulate. Great. What is next? Second postulate. Second postulate is called stationary orbits. Stationary orbits. So, in first postulate, electrons are revolving around the nucleus in a circular orbit, in a discrete circular orbit. So here, whatever the electrons are rotating around the nucleus, this is the nucleus, right now. Right now, these electrons are rotating. These electrons are moving in a circular orbit or discrete orbits, which doesn't radiate any energy. So we'll discuss later how much energy it will have in this orbit, how much energy it will have, right? So why it doesn't radiate energy? Then when it is radiate energy, we will discuss later. So here, this electron is rotating in this direction, in this form. So we can say that shells. We can say that it's a principal quantum number K shell, L shell, M shell, and N shell, right? So these are called stationary orbits. While rotating electron in the stationary orbit, it doesn't radiate any energy. It has some particular energy, but it doesn't emit energy. అంటే ఇది సర్క్యులర్ షేప్ రొటేట్ అవుతుంది. ఆ స్టేషనరీ ఆర్బిట్స్ అంటాం, వాటి మనం ఇండికేట్ చేస్తాం K, L, M తో ఇండికేట్ చేస్తాం, బట్ ఇట్ డజంట్ రేడియేట్ ఎనర్జీ. దట్స్ వై యూ కెన్ కాల్ ఇట్స్ ఏ స్టేషనరీ ఆర్బిట్స్, రైట్? సో దెన్ నెక్స్ట్ కండిషన్ ఇస్ how we decide the orbits. Only this is the orbit, it's orbit. Why? How we can decide the orbits? మనం ఎలా ఆర్బిట్స్ అని డిసైడ్ చేస్తాం? ఇక్కడ ఎందుకు లేదు ఆర్బిట్, ఇక్కడే ముందు ఎందుకు ఉంది అంటే, సో దేర్ ఇస్ ఏ వన్ మోర్ కండిషన్ ఇస్ దట్ ది ఆర్బిట్స్, ద ఆర్బిట్ లో ఎలక్ట్రాన్ రొటేట్ అవుతుంది, దాని మాస్ m, ఎలక్ట్రాన్ యొక్క మాస్ m, దాని వెలాసిటీ v, రేడియస్ ఎంత అంటే r, రైట్? So here angular momentum L is equal to mvr. Angular momentum should be equal to the mvr. ఈ ఏ ఆర్బిట్ లో రొటేట్ అవుతుంది అంటే ఈ యాంగులర్ మొమెంటం mvr అనేది it should be equal to the integral multiple of the h by 2pi. Integral multiple of the h by 2pi. సో ఇక్కడ ఎలక్ట్రాన్ ఉంది, మాస్ ఉంది, ఎలక్ట్రాన్ కి వెలాసిటీ ఉంది, రేడియస్ ఉంది. ఇక్కడ మాస్ ఉంది, వెలాసిటీ ఉంది, రేడియస్ ఉంది. ఇప్పుడు ఈ ఆర్బిట్ ఎలా సెలెక్ట్ అవుతుందంటే, సో ఇట్ షుడ్ బి ఈ కండిషన్ సాటిస్ఫై అవ్వాలి. ఆర్బిట్ అనేది ఈ కండిషన్ సాటిస్ఫై అవ్వాలి. ది యాంగులర్ మొమెంటం L is equal to యాంగులర్ మొమెంటం అంటారు. యాంగులర్ మొమెంటం L is equal to mvr. ఇట్ షుడ్ బి ఈక్వల్ టు ద nh by 2pi. ఏమంటే ఇంటిగ్రల్ మల్టిపుల్ ఆఫ్ h by 2pi. అంటే ఏ ఆర్బిట్ లో వస్తుంది మనకి ఫస్ట్ ఆర్బిట్ ఏంటి? mvr is equal to where n is equal to 1 2 3 and so on, h by 2pi వస్తుంది. నెక్స్ట్ ఆర్బిట్ ఎంత వస్తుంది మనకి? 2h by 2pi. నెక్స్ట్ ఆర్బిట్ 3h by 2pi. ఈ కండిషన్ సాటిస్ఫై చేసిన ఆర్బిట్స్ లోనే రొటేట్ అవుతాయి అంటారు. వాటి మనం స్టేషనరీ ఆర్బిట్స్ అంటాం. ఆ స్టేషనరీ ఆర్బిట్ లో రొటేట్ అయ్యేటప్పుడు ఇట్ డజంట్ ఎమిట్ ఎనీ ఎనర్జీ. సో దిస్ ఇస్ కాల్డ్ ఈ రూల్ ఏమంటే we can call this rule is quantization rule. So mvr is equal to nh by 2pi. L is equal to mh by 2pi because L is equal to mvr. This is called quantization rule. Right. So this is the second thing. Next, third thing, stationary orbit. Next, third thing, energy transition. So in last two we say that electron is rotating a stationary orbit which does not radiate any energy. మరి ఎప్పుడు ఎనర్జీ రేడియేట్ అవుతుందంటే ఆ ఎలక్ట్రాన్ అనేది ఒక వన్ ఆర్బిట్ నుంచి ఇంకొక ఆర్బిట్కి వెళ్ళినప్పుడు, రైట్? లోయర్ ఆర్బిట్ టు హైయర్ ఆర్బిట్ అవ్వచ్చు, లేకపోతే హైయర్ స్టేట్ టు లోయర్ స్టేట్ అవ్వచ్చు, రైట్? సో దెన్ ఎనర్జీ ట్రాన్సిషన్. Right. Now, this is the there is one electron is there. Here another electron, here another electron. Here this is the radius which moves with in a stationary orbit. Which ఈ ఎలక్ట్రాన్ మనకి కొంత ఎనర్జీ ఉందనుకోండి, E1 ఎనర్జీ, ఈ ఎలక్ట్రాన్ కూడా కొంత ఎనర్జీ ఉంటుంది, E2, ఈ ఎలక్ట్రాన్. సో నేను what I say that the electron has some particular energy but which does not radiate energy. ఈ దీనికి కొంత ఎనర్జీ ఉంటుంది, ఈ స్టేషనరీ ఆర్బిట్లో రొటేట్ అయిన సేపు కూడా అది ఎనర్జీని అనేది రేడియేట్ చేయదు, ఎమిట్ చేయదు. ఎప్పుడు ఎమిట్ చేస్తుంటే whenever this electron jumps from lower orbit to higher orbit or from here to here, right? So whenever the electron is jumps from lower orbit to higher orbit, right, it absorbs the energy. Lower నుంచి బయట higher వచ్చినప్పుడు ఆ ఎలక్ట్రాన్ అనేది ఎనర్జీని అబ్జార్బ్ చేసుకుంటుంది. But whenever it jumps from higher orbit to lower orbit, right, it emits the energy. It emits the energy. So how much energy it emits or how much energy it absorbs? ఆ ఎనర్జీ ఎంత ఎమిట్ అవుతుంది, ఎంత అబ్జర్వ్ అవుతుంది, అబ్జర్వ్ అయిన ఎనర్జీ ఏ ఫామ్ లో ఉంటుంది, రైట్? ఫర్ ఎగ్జాంపుల్ ఇక్కడ నుంచి మనకి ఇక్కడికి వచ్చినట్టు, రైట్, ఏం ఫార్ములా మనకి E2 minus E1 is equal to h mu. E2 అనేది హైయర్ ఆర్డర్ ఎనర్జీ. ఇప్పుడు ఇది మనకి లోయర్ ఆర్బిట్ నుంచి హైయర్ ఆర్బిట్ వచ్చినప్పుడు చెప్తున్నాను. E2 minus E1 is equal to h mu, రైట్? లోయర్ ఆర్బిట్ నుంచి హైయర్ ఆర్బిట్ వచ్చినప్పుడు ఇది అబ్జార్బ్ చేసుకుంటారు ఎనర్జీ అనేది. మరి హైయర్ ఆర్బిట్ నుంచి లోయర్ ఆర్బిట్ వచ్చినప్పుడు ఎంత ఫార్ములా? E1 minus E2 is equal to h mu. ఇక్కడ ఎనర్జీ ఎమిటెడ్ రేడియేషన్ ఎమిటెడ్, రేడియేషన్ ఎమిటెడ్ ఏ ఫామ్ లో ఏం చేస్తుందంటే ఫోటాన్, లైట్ ఫోటాన్ ఫామ్ లో ఏం చేస్తుంది? ఎమిటెడ్ ఇన్ ద ఫార్మ్ ఆఫ్ electromagnetic wave. electromagnetic wave ఒక ఫామ్ నుంచి ఇంకొక ఫామ్, ఒక ఆర్బిట్ నుంచి ఇంకొక ఆర్బిట్ కి లైట్ వచ్చినప్పుడు ఇట్ ఎమిట్స్ ఎనర్జీ ఇన్ ద ఫార్మ్ ఆఫ్ ది ఎలక్ట్రోమాగ్నెటిక్ వేవ్ ఆర్ ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్, రైట్? సో ఇక్కడేమో ఎమిట్ చేస్తుంది, ఇక్కడేమో లోయర్ నుంచి హైయర్కి వెళ్ళినప్పుడు అబ్జార్బ్ చేస్తుంది, absorb energy. So this is the formula. E2 minus E1 is equal to h mu. Here h is the Planck's constant. Mu, you can say it is a mu. It's a frequency. V is nothing but a frequency. That much of frequency is emitted while absorbed, while coming from higher order to lower order, lower order to higher order. These are the three rules or three laws proposed by the Bohr, right? Now from this, if you observe here, there is a nucleus, is there? Nucleus. Around the nucleus, electrons are rotating. Around the nucleus, electrons are rotating. So this is the electron, some electron. Electrons are rotating here. What is the radius of this electron? What is the radius? Right. How this is called K shell L M. Principal quantum number K is equal to N is equal to principal quantum number. We can call it say N is equal to 1. దీనికంటే n is equal to 2, n is equal to 3. Here you can call n is equal to 1, 2, 3 are called principal quantum number, right? N is equal to 1, then what is the radius? What is the velocity? If you observe here, this electron is very near to the nucleus. It is affected by the nucleus, so it is strongly bound by the nucleus, so it has a more velocity. So more kinetic energy. Now, so what is the velocity of this one and what is the radius of this one? and what is the energy of this one, and what is the electron, what is the this electron, what is the energy of this electron. Next, radius of this electron, what is the velocity of this electron, what is the time period of this electron, what is the kinetic energy of this electron, and potential energy of this electron. We'll discuss all these things. Right? So now, first thing is, from this, what we are going to discuss here now. We discussed already laws, Bohr's atomic law, law. In that, circular orbit, stationary orbit, and transition discussed here. Now, we derived the formulas. We have some formulas for radius of orbit. Radius of orbit. Next one is velocity of orbit. Velocity of orbit. Next one is potential energy. Potential energy. Fourth one is kinetic energy of electron. Kinetic energy of electron. Next one is total energy. Total energy of electron. Then time period and frequency. Time period and frequency. We'll discuss later. So these are things about all these things we'll discuss in the next video, right? And there is so many formulas are there. It's very important formulas on these things. Thank you.